Hi, everyone. This is Miss Rapp. I hope you're doing well. This is Algebra 2, Unit 6, Lesson 7. Whoops. Lesson 7, pages 77 to 81. Let's get started. Okay, we are doing polynomial long division. And yes, I know you thought you were done with long division when you were like in 5th or 4th or 3rd grade, maybe 6th grade, but it's back. And this is a lesson where a lot of like old stuff that you've done, like long division, really comes into play with like new stuff. So it's cool to kind of see how your really elementary strategies actually can work with everything. So let's get started by doing some long division. And I recommend pausing the video and seeing if you know how to do this on your own. So like the number goes in, this goes inside the house. Guys, I still talk to myself like that. So this is our setup. So just to walk you through long division, you think, how many times does 21 go into 6? Oh, it doesn't. So I put an X there. How many times does about how many times does 21 go into 67? Well, let's see. 21 times 3 is 63. So that's the closest I can get. So I put a 3 up here. And then I go 3 times 21 is 63. And then you're going to subtract. The 6's cancel. 6 minus 6 is 0. And then you get a 4 here. And then you bring the next number down, right? Long division is weird, you guys. And so then I ask myself, well, how many times can 21 go into 42? Oh, well, that's actually perfect. So I get right there a 2. 2 times 21 is 42. And then remainder 0. I like to put a smiley face. Okay. Okay, let's do the same thing over here. How many times does 15 go into 1? No, doesn't work. How many times does 15 go into 15? Once. So then I'll go 1 times 15, and I'll throw that 15 here. And that turns into 0. So I bring down. So this ends up being 0, obviously. So I put a 0 here, and then I bring down this 3, and then I bring down this 8. And then how many times does 15 go into 38? So that's about 2 times. So then that's 30. And then I get just 8, and I got to bring down that 4. 15 goes into 84 about 5 times, and that's going to be 75. So when I do this, 7, 14. So that's going to be 9, but 15 doesn't go into 9. So this is where we bring in a decimal. And I put a decimal here as well. And I bring that down. I have 90. 15 goes into 90 6 times. And that's our answer. So you're just seeing how many times it fits. Okay. So let's move on. Some long division review. Factor the trinomial x squared minus x minus 2 into the product of 2 binomials. Use your knowledge of inverse operations to explain why this must be true. Using this example as evidence, can you conclude that factoring and division are the same? Explain why or why not. So if I factored this, I would get x I would get x plus 2 times x minus 1 over x minus 1, because this is what that factors to. This is just 1 over 1, right? This is just, when something's divided by itself, that's 1 over 1, so you're just left with this. Pretty cool. Okay, let's look at this. We can use long division of polynomials to find factors when they have a degree greater than 2 and cannot be factored using a grouping or pattern. So this is what you do when you can't factor. In order to find factors with polynomial, what will I need you to provide you? So if you want to find the other factors, I need to give you a factor or a root. I need to give you something to start with. I can't just say, hey, factor this or divide. We have to do division. If there is a remainder after dividing, the given polynomial is not a factor. If there is no remainder, then it is a factor. Okay, let's try this out. So using the given solutions, create the factors. So if I tell you the answer is x equals -5, that had to come from this. Okay, well, if x equals 4, that had to come from this. If x equals -12, that had to come from this. So that's good practice. So we are going to do 1, 2, 3 examples to talk about long division. Let's go for it. Is x plus 3 a factor of this polynomial? So I want to know if I could divide this into that. So here's how you set it up. You put the you put the factor on the outside, and then you put everything on the inside, everything else. Okay. Here is the process. I have x to the power of 1 plus 3. What do I have to multiply x by to get x to the 4th? Oh, well, x to the 3rd times x is going to be x to the 4th. So then what I do is I go x to the 3rd times x, and I get x to the 4th. X to the 3rd times 3, I get plus 3x to the 3rd. We're going to deal with this just like the other one. That cancels. Remember, guys, minus sign. X to the 3rd minus 3x to the 3rd is going to be negative 2x to the 3rd. The goal is that you're going to lose a degree each time. And then every time you do this, you're going to bring another one down. So I drop this down, negative 11x squared. Okay, now I'm going to do the same thing, but I'm going to use this row. And guys, this takes practice, just like everything else we've been doing. I want this x to match this. So what times x gets me this? Okay, well, I need a -2, and I need 2 more x's. So negative 2x squared goes on the top. Negative 2x squared times x, put my big subtraction sign. Don't lose the subtraction sign. That's so important. I get negative 2x cubed minus 6x squared. The goal is to always get rid of the first number. So I got rid of that first number. Now I'm getting rid of this. Negative 2x cubed minus negative, so this becomes adding. So this goes away. Great. Negative 11x squared minus negative 6x squared is going to be really adding. So when I add them, negative 11 plus 6x squared is going to be negative 5x squared. And then I drop one down, minus 5x. So now I do the process again. I want this to match this. So that's going to be a negative 5x. And then I do the multiplication. Negative 5x times x is going to be negative 5x squared. And then negative 5x times positive 3 is going to be minus 15x. That goes away. Negative 5x minus negative 15x. Well, that's really adding. So that's going to be positive 10x. And then I bring down my 19. How do I get here to here? Well, I have to multiply by 10. And then when I multiply by 10, I get big minus sign, 10x plus 30. So that goes away. That's good. But then I get negative 11 here. And I've run out of things to drop down. So that's my remainder. So to write your remainder, here's our final answer. I would say that when I did this division, I got x cubed. I'm going to take this answer right here. Minus 2x squared minus 5x plus 10 plus negative 11 over x plus 3. That's how you write your remainder. So because I have a remainder, it is not a factor. That's our answer. This whole thing is our answer. Okay, we are going to do this 2 more times, then we're going to do it in class, okay? Example 2. This is another way that I'll ask the question. Confirm that the 0 provided is a solution to the function. So it's telling me that there's no remainder. So I'm going to do the math and see if this works. So if they give me x equals 2, the factor is x minus 2. So let's set this up. And let's double check 3, 2, 1, 0. We're not skipping degree. I'll show you what happens when you skip degree in the next one. Also, this is just one strategy for dividing polynomials. You'll learn another one in the next lesson. Okay, so step 1, I want x to match 5x cubed, so I'm going to need 5x squared, because 5x squared times x gets me this. Big minus sign, let's do that multiplication. 5x squared times negative 2 is negative 10x squared. That goes away. 4 minus negative 10 is actually adding 10. So I get 14x squared, and I bring down negative 20x. How do I get these to match? Well, I need a 14 and an x, so plus 14x. Do the math. I do this times this. And I get big minus sign, always goes there because we're doing long division. 14x squared minus 28x. That goes away. 20 minus negative 28 is going to be a positive 8. And then I bring down my 16, my negative 16. I want these to match, so I just need to add 8. Big minus sign. 8 times x is 8x. 8 times negative 2 is negative 16. Those cancel, and these cancel. We have a remainder of 0. I like to make mine a smiley face. So, no remainder. So, x equals 2 is a factor. Okay. Pause, take a moment, look at what I just did. It's really like a lot of jumping around. It says, after confirming the 0, how can we find all the other solutions? We could factor the remaining polynomial. Okay, we have one more example. Let's do it. Okay, example 3, skipping degree. So we give a lot of examples in these videos because these are the types of examples we will show you in class. So different types of examples have different strategies. So this example is going to be skipping degree. It says, is x minus 10 a factor of x cubed minus 2x, 10x squared minus 3? Skips term with x. So here's what we do. We're going to set it up. But when I write it down, I'm going to put a placeholder. That's my placeholder. Okay, make sure you do that. So now we're going to go through it the same way. I want these to match, so I would need x squared. So a big minus sign, x cubed minus 10x squared. Those go away, and those go away. So then that I can't really do much with it because it's 0x. So then I just have negative 3 as a remainder. How do you know if it's a remainder? Well, I know it's a remainder because nothing times x will get me negative 3. Like I can't do anything. So our answer is x squared plus negative 3 over x minus 10. Because there's a remainder, x minus 10 is not a factor. So the biggest thing about this was that placeholder. Okay, that is the lesson. Please do the video check-in. Guys, I know this is hard. Keep working through it. You can do it. I've taught this class for a long time now, and it takes hard work and dedication and questions. If you don't ask questions, it'll be very hard. Okay, guys, have a great day. Don't forget your video check-in. Bye.